Okay, so now let's talk about isotopes and atomic mass. So all an isotope is it's an element or a version of an element, which will make more sense when we look at an example, that has the same number of protons and electrons, but it has a different number of neutrons. So let's take an example of carbon. When we look at the periodic table, we'll see carbon that looks like this. Okay, so its atomic number is 6 and its mass is written something like 12.011. Okay, now we see these different versions of carbons, which are actually isotopes. So we have carbon 12, carbon 13, and carbon 14. So what I want us to do to just make sure we understand what an isotope is to figure out how many protons and neutrons there are in each of these isotopes. So carbon will always be the sixth element in the periodic table. It will always have a Z that is equal to 6. So that tells us the number of protons. So in each of these, carbon has 6 protons. But what's different between these is the mass number. So this one has a mass of 12, this one has a mass of 13, and this one has a mass of 14. So remember, to calculate the number of neutrons, we want the atomic mass, or molar mass, minus the number of protons. So in the first case, we have the mass of 12 minus 6, and we get 6 neutrons. In the second one, we get 13 minus 6, we get 7 neutrons. And finally, we get 14 minus 6, and we have 8 neutrons. So we can see that the number of protons in each of these has stayed the same, but the number of neutrons is different, and that's what tells us that these are isotopes of each other. So they're all isotopes, or you can think of it as versions of carbon, and they all exist in nature. So the other thing to know is that different isotopes, and these numbers are going to be different depending on which element we're looking at. But for carbon, carbon 12 is present 98% of the time. So 98% of the time, we're going to come across a carbon 12 molecule. And 1.07% of the time, it's going to be a carbon 13 molecule. And very, very small percent of the time, it'll be a carbon 14 molecule. The reason why all of this is important is because it's going to come in handy when we try to calculate our atomic masses. So let's talk more about that now. How are the atomic masses in the periodic table calculated? So just for review, the atomic mass is again this number here, that larger number written usually underneath the atom in the periodic table. So we see that the number is around 12 for carbon, but this does not mean that each carbon atom in nature is going to have a mass of 12. As we saw here, carbon can have these different masses. So to calculate this mass here, it's actually looking at a weighted average. So it's like an average where we are taking into consideration each of these different masses, but it's a weighted average because we're also taking into consideration the percentages of each. And using that, I'll show you guys the calculation, we can come up with this atomic mass. Okay, so this is just going over what we just said. It's a weighted average based on the relative abundance of isotopes. So the calculation is here, and what we're doing is you're taking each isotope. So in carbon's case, there are 3 different isotopes. So we'd have to do this calculation for each isotope. So you take the mass of isotope 1, multiply that by the abundance of whatever isotope 1 is, and then this represents sum. So you're going to add and do the same thing for isotope 2 and do the same thing for isotope 3 and so on until you've covered all the isotopes. So in carbon's case, there would be 3 isotopes you'd do that for. Now, one thing I just wanted you guys to watch out for on exams when you're doing these calculations is that, so we are plugging in the mass of each isotope here, but then for the abundance of each isotope, make sure that you're plugging in these values in their decimal forms, not percentages. So for example, above, we were told that the relative abundance of carbon 12, or this is another way of writing carbon with a mass of 12, that particular isotope, is 98%. So we don't want to plug 98%, like 98, as an abundance. Instead, this would be the correct way of writing that. And we're about to see that soon in some calculations, so we'll have a chance to practice that. Okay, so let's start off with a more simpler problem. So this example, we're solving for atomic weight. So it says chlorine can be found in nature. So this is one of the isotopes, chlorine with a mass of 35. And then they're actually telling us a more specific mass. This more specific mass with decimals, that's the one we're going to want to use in our calculation. And we're told the abundance of that isotope. And we're also told we have chlorine 37, its mass, and its relative abundance. What is the average atomic mass of chlorine? So to solve for this, we're just going to write out the equation we just saw. So now let's take the first isotope, so chlorine 35. So we want the mass of that isotope multiplied by the abundance of that isotope. We're going to add and do the same thing for the second isotope. So now for this question, it's just a matter of plugging in each of these values and we'll be able to solve for atomic weight over here. So the mass of Cl35, we said we want to use this number over here because it has more decimal points. It's way more specific than just using 35. So we want to make sure we're plugging in this on a test. Okay, and now the abundance. So this is the abundance. Remember that if we plugged in 75.78 here, we're going to get the wrong answer. You want to plug in a decimal. So to convert any percentage into a decimal, we're just going to divide by 100. Now we do the same for 37 chlorine. So this one has a mass of 36.966. And we multiply by its abundance, but again, don't forget we have to divide that by 100 as well to get a decimal. And so our decimal relative abundance is 0.2422. So now when you plug those numbers into your calculator, you should get 35.45 as your atomic weight, and that would be the correct answer. So there's no further calculation needed.
Want more bite-sized lessons? Check out the Wise free trial at wizeprep.com. Oh, and subscribe to our YouTube channel while you're here.